Hello. Okay, thank you. It's working now. Hello. It's working. Okay, good. Okay, thank you. At least my microphone is now working. Hello. Thank you for coming back. So my mic, I, I can be heard now. Hello. Who is in the house? Kaiser. Uh, email you. Please, Joshua. Please log in again. Kaiser. Okay, thank you. So it's sometimes difficult to you need to reset, no, when something is not working. So good that we're back. For this week, we are going to finish one module. No, that's module 4. I have to upload that this afternoon. So you can work with that until next week. So we have only one module per week. And after that, we have 3 more modules for the second quarter. For the second quarter. Okay, I think some of your classmates have not returned yet because of some interruption. Anyway, we can just continue. They will just log in by and by now if they want to come back. Okay, so thank you very much, Kaiser. And our problem here is the net connections. Now we are affected. It's not really stable. But anyway, we can just continue. Uh, so for this time, may I pray before I start? Let's pray. Dear God, loving Father, we come to you as we start with our class. We pray for your guidance that may learn and understand our discussion today. Thank you that you will protect us from harm and you will keep us safe always, O Lord. Thank you for hearing and answering our prayer in Jesus' name. Amen. Okay, so let's start. Kaiser, some classmates of yours, no, have not returned yet. You're about there are about 4 of you. So this time I'll be discussing physical properties of solution. Okay, good morning, Emilio. Good morning. So thank you for coming back because of the interruption. I think my voice is now clear enough. I really knew that my mic is not working because of the what is this one, the feedback. So we'll start now. Our discussion for this morning is on physical properties of solution. So we know already what are solution. Solutions are kind of mixtures which which uh, which is homogeneous in nature. That means you cannot see, or there is only one phase. Now one phase as you could see physically, and it is made up of the solute and solvent. That's for your what? For your junior high school. You know that already. So this time we will add your knowledge on solutions. But before that, may I read this MBCE booster. No, so a short story about elephant rope. So just listen. This is one of the more popular inspirational stories around, and all with good reason. The elephant rope, PC. The elephant rope isn't only an engaging story, but it is incredibly motivational also. The story begins with a man who passed elephants which were tied up. He suddenly stopped in his path and became confused by the fact that such a tiny rope held the massive creature. So the man is very what or shall we say surprised surprised why the elephant, a huge mammal, is tied to a very, very small rope. So that man was confused. Of course, these elephants could escape easily and quickly. Imagining, a very, very small uh, rope. Elephants can even break big, large or big trunks of trees. But for this small rope, he couldn't. Here were no chains creatures. Of course, these elephants could escape easily and quickly. For some reason, these elephants did not break away from their tiny bit of rope. Curiously, he asked the trainer nearby, but these elephants were just stood there. Why were they not attempt to get away, despite being clear that they could? The trainer explained that when the elephants were younger, when they are still small, they were tied to the wall using the same bit of rope. So they are still small and they are used to that small rope. At that age, the rope was strong enough to stop them from escaping. They tried several times when they are still younger and they couldn't escape. Now, as they grew up, despite getting bigger, they were conditioned to believe that the rope was holding them and they cannot break the rope. They never once tried to break them free. So they never attempt again because they assumed that the rope could still hold them and they cannot break even when they are already big enough and much stronger. In short, the elephants believed that they couldn't, so they never tried. This baffled the man now. This baffled the man. Now, it's strong metaphor to what many of us do in our everyday life. We often fail once and never try again. So we go through life holding on to a simple belief that we cannot do something anymore because we tried once and we fail. So ing ana dai kadaghanan no sa ato. We are like elephants that we believe since we failed before, so we don't believe anymore that we can do it right now. So the valuable lesson that we can get out of this story is that life isn't about control. It's about learning, and we should never give up. We have to keep trying. Otherwise, we will metaphorically be trapped and contained. If something prevented you the first time you tried, don't let that make you lose your hope. Imagine if elephants have tried just one more time, they can easily get away. Okay, so yung ana ang panato for this morning. No? So, I hope you learned something from this MBCE booster. Now, for me, we have different style in doing this. Now, different style of teachers. For me, I use this story. If you just read the story, later on you can use that one. Even when you grow older, no, you can still remember these short stories that teaches us valuable lessons in life. Okay, now let's go to our lesson proper now. So our target, what you need to know, use different ways of expressing concentration of solution. So the solution, we know that solution don't have a specific amount of mixture. So there are different concentration, whether the solute is dilute or concentrated. So we have that different concentrations of solution. Now, how to express that is through percent by mass, mole, fraction, molarity and molality, percent by volume, or we have the ppm, parts per million. I think you have encountered these different terms already, even in grade 11 or in grade 10. No? So the same principle, the same things we are going to study. We will just add, performs stoichiometric calculation for reaction in solution. So just little computation. Differentiate the colligative properties of non-electrolyte solution and of electrolyte solution. Okay? So you have there for your pretest what I know. There are about 5 questions or 5 items only. No, 10 items. No, so you are going to answer that one, multiple choice. So like for example, the following are units of concentration, except I have mentioned that a while ago. Percent by mass, mole fraction, parts per million, mole. So I'm going to upload this one. I think this topic is for next week, because this week we are still on the what, phase diagram. We are still on the phase diagram. So we are going to what? We are going to answer this next week pa kini siya nga topic. So we are 1 week ahead, because right now supposed to be for this week our focus is on phase diagram. Okay, I'll just upload no the video for phase diagram. You need to view that no later on. You need to view that so that you can understand all about phase diagram. Okay, so let's continue our discussion. In the previous lesson, we discovered the phase changes in terms of accompanying changes in energy and forces between particles. Many chemical reaction takes place between ions and molecules. Yes, we know this. Now in our what lesson is that? Ions and electrons during the intermolecular forces. Now we discussed this one, forces. So its ions or molecules dissolve in water or other solvents rather than pure solids, liquids, or gases. Previously, we looked at the properties of gases, liquids, and solids. In this lesson, we will examine the properties of solution. That means it's already a mixture. No, it's already a mixture of two or more materials or substances. So we call it as solution. And one thing about solution, as I explained a while ago, there is only one phase. You cannot see the other particles with your naked eye. So because it shows only one appearance. Quantitative study of solution requires knowing its concentration. So because we cannot see the particles in the solution, either the molecules or the ions. That's why it is much important to study solution based on their concentration. Concentration. Okay? Now, how important is this study? Now, if you discuss this, like for example, in our blood chemistry, no, there is concentration of different, even salt or even other nutrients in our blood. No, so that's why This is very, very important to study to learn about. Now, several different concentration units are used by chemists. Saan paggamit aning how important is this topic to us? So, chemists study this, each of which has strengths as well as drawbacks. Let us examine the units concentration. Percent by mass, mole fraction, we have the molarity, we have the molality, percent by volume, and parts per million. No, parts per million. So we have the types of concentration. Okay. So first is types of concentration units. Let's discuss first the percent by mass. Okay, what is the mass? Mass is, we know that this is the amount present in the body of the material. So in a solution, you are to get the mass of a solute and the mass of the solvent so that you will know the concentration. No? Again, so how will you know or how will you study the concentration of a solution? One way is by examining the mass of the solute and the mass of the solvent. Okay? So we call this one as percent by mass. Percent by mass. There is an mathematical equation no regarding this, but what my intention right now, because you cannot see what I'm doing, no, but I'm just presenting to you the importance and the view, the overview on how to get the concentration. So one way is by examining the mass of the solvent and also the solute. So we call that one as percent by mass. Okay? So we have a very simple computation with that, and you know that you have encountered that many times no, in your sciences in the lower years. Okay, so first, percent by mass. Next, how can we examine the concentration of a solution? Number two is through mole fraction. So we know already that what is a mole. No? So even the equivalent of the mole, you know that. Okay, welcome Joshua. Yes. Good morning, sir. My internet is terrible right now. Oh, I have experience also. Sometimes my problem here, no, class, when the internet is not working in our house, I go to the academy. But when I reach there, sometimes the same thing is happening. So I will have to go back here. Sometimes there is good connection in the academy, so I will go there. No, so anyway, that's our common problem. No problem with that. We're used to that. As long as we can just adjust, adapt, and then make something no, that we can solve this little problem of ours. Anyway, you can also understand now because that's your problem also. It's our common problem rather. Okay, so first I told you how to study the concentration of the solution. First is by examining the mass of the solute and the mass of the solvent. And then uh, by doing that, we are actually studying the percentage of the mass of the solute, percentage of the mass of the solvent. Okay, number two, another way to examine the concentration of a solution is through mole fraction. The mole fraction of a component of a solution is we have is unitless. Wala na siya unit. So it's not like other units or other measuring tool, there is really an equivalent or other variable, there is actually a unit after. But the mole is unit less because it too is a ratio of two similar quantities. So what is the fraction? So we are given the percentage of a mass of the solute in the solution. Hence, we can calculate the mole fraction through number one. How will we do it? First, converting the concentration units based on the mass or moles of a solute and solvent or mass percentage. It is useful to assume a certain total mass of a solution. So, in number one, we examine the mass of the solute and the solvent. So we have now the idea on how to solve for the mole fraction because those mass, uh, what is that one? Percentage is useful in order that we can solve the mole fraction. So step by step, now process, step by step process. Okay. Number two, changing the masses of the components to number of moles. Okay, so we are going to change the mass of the components of the solute and the solvent to number of moles. So we will do that, no, in order that we can continue to solve for the fraction. First, we change the components of, like for example, ethanol and water. Di ba? You have that molar mass. In grade 11, you have that molar mass. You know that already. Okay, number three, substituting the values obtained in the formula and solve for the mole fraction of the solute and the solvent. Okay, so there is step by step. So don't worry about this because we will do it uh, step by step. No? So types of concentration of units. First, we have the percent by mass. Number two, you can solve for the concentration of solution by way of mole fraction. Now, mole fraction. Okay, not only that, we have also another way of knowing the concentration of solution through what we call as molarity. You always encounter this term molarity, molality, no, molarity and molality. Even myself, I still I cannot na remember sometimes what is this molality and molarity. Okay, so let's have first molarity. Molarity is defined as the number of moles of solute. Again, molarity is defined as the number of moles of solute in 1 liter of solution. So when we talk about molarity, these are the things that you need to remember. Molarity is what? Number of moles of solute. In what? In the volume. In what volume? 1 liter of solution. Okay? So this time, it is not like mole where mole fraction that there is no unit. Since here in molarity, you have moles of solute over volume of solution. Again, uh, moles of solute above over moles of volume of solution in liter. So when we say volume of solution, that includes also the volume of solute and volume of solvent. So that is molarity. The unit of molarity, therefore, is mole over liter. Okay, because in volume, we are using liter. Again, I'd like to repeat, what is molarity? It refers to mole of solute over volume of solution. So the unit now is mole over liter. Because in volume, we are using liter. Liter. Okay? Now, number 4. Number 4. Okay, again, I will review how will we know the concentration of a solution. Number 1, by examining the mass of the solute and the mass of the volume. We call it as percent by mass. Number 2 is to what? To know the true mole fraction. No, mole fraction. So mole fraction equals to mole of a substance over the sum of moles of all component. Okay? So you have one mole of a substance over all other components. That means the solute and the what? Solute and the solvent. And then there is no unit for mole fraction. Okay, number 3. How can we examine or how will we know the concentration of solution? Through molarity, by way of studying the mole of a solute over the volume, of a solution, and the unit is for mole over liter. Number 4, molality. So the only difference here is R and L. Molarity, molality. Now, what is molality? Now, it is the number of moles of solute dissolved in 1 kilogram of solvent. Kanina, one mole. Say molarity, mole of a solute. Here, still the same, mole of a solute. But this time, over 1 kilogram. Kanina, over 1 liter of a solution. So the only difference is the unit of the solution. In molarity, it is in liters. In molality, it is in kilogram. Okay, so that's the only difference between the molarity and molality. No, so the word alone has a very simple uh, has little difference, R and L. So when it is R, it is L. That means it is liter below. When it is molality, when it is L, it is kilogram. Okay, so we have now this one. Okay, so we have learned already 4 ways of knowing the concentration of solution. We will add another one. This is what we call percent by volume. Uh, Kanina, percent by mass. So we know that the mass, and you know what device is used to measure the mass. This time, we are going to know the concentration of solution by studying the volume. So we call this one as percent by volume. Percent by volume. The percent by volume is used to express the concentration of solution when the volume of a solute and the volume of solution are given. Okay, so when two variables are given, no, the what? The volume of a solute and the volume of a solution are given, then we can easily compute for the percent by volume. Okay? So the formula for that is percent by volume over volume of solute over volume of solution. Maura gyapon sa kanina, no, katong uh, molarity and molality, no, so they are still using unit, so volume of solute, volume of solution times 100. So we are given the volume of solution dissolved in a certain amount of solvent. So we can easily calculate the volume of percent using this kind of equation. Percent by volume equals volume of solute over volume of solution times 100. Okay, so we have now 5 ways on knowing the concentration of solution. We'll have another one. This is what we call parts per million, ppm. ppm, parts per million. Now, what is this all about? A concentration of a solution that contain 1 gram of solute and 1 million of milliliter of solution. Same as 1 mg solute equals 1 L solution. Okay, so what is parts per million? This means it's a concentration 1 gram. Again, 1 gram of solute and 1 million of ml. What is that solvent? Or 1 million of ml of solution. That is solvent. The same thing as 1 milligram is equal to 1 liter. So in 1 milligram of solute, you compare it with 1 liter of solution. So would create a very small percentage concentration because by million, parts per million, this is used on uh, giving or using small amount of solute in a very big amount of solvent. Again, I would like to emphasize this. This is very useful procedure, no? And we are using this. We observe this in our everyday life, but you don't know, maybe because you don't know yet the application. Like for example, in reservoir of water, no? They are using chlorine to purify, no, to purify that so that it can be distributed to different households. But don't you know that when you overuse, when the amount of chlorine you mix it with water is so much, then there would be a problem. The health condition of people using that would be affected. So that's why it's only a small amount of chlorine is added per per how many liters. No, you cannot count that by liters because you can how many liters are there in one reservoir. So they are using now cubic meters instead of using liter. And there is only small amount of chlorine is used compared to a very large volume of solvent, the water. Okay? So that's why this procedure is very important to know the how many parts per million is needed. So we'll have a computation. For example, if we have two, what is this one? Dump trucks. There, I think if there are two truckloads, they are using the one, di ba, kanang panila? I don't, I cannot, what is that, the term, no? Kanang ilang ginasudlan. Ingana, nagpahatod ka. And then you are going to purify that using chlorine. So you are going to compute how many cubic meters of water are there and the small amount of chlorine you need to use for that. No, so by doing that, you are using this procedure or technique about parts per million. Okay, so why per million? Because 1 gram per 1,000 1 million ml. 1 gram is to 1 million ml, or 1 milligram is to 1 million of uh, or 1 liter in a solution. No, so that's still the same ratio and proportion. Okay, so to recap, to summarize, no, the ways on how to know the concentration of solution. First, we will we will have the percent by mass. Then we have the mole fraction. We have also the molarity. We have the molality, and then we have the other one, percent by volume, and number 6, parts per million, parts per million. So by doing that, we study, we analyze, we can determine rather the concentration of solution. Why we need to study the concentration of solution? Because we cannot see all the particles in a solution. So to understand more about solution, it is rather good to study the concentration rather than to study the particles, no, the particles there. So it's the concentration between the solute and the solvent. Okay, so I think we have done, so we finished discussing that topic, and that's the myth. No, that's all about this module, concentration of solution. No, concentration of solution. So by knowing the concentration of solution, there are 6 ways on how we know the concentration of solution. So within this week, unsa na karon? Tuesday. Tuesday, tomorrow until Friday, we have still time. We can finish all of this. We are a little bit advanced, gani, no? So we can finish this within this week. So I hope you also you also doing your answering your your activities in the Moodle. But anyway, I was a little bit late, no, in uploading the lesson 4. Lesson 4, 'di ba? Lesson 4. So we discuss in advance, but for that week we also answering the previous topic in last week, no? So that's what we are doing. Okay? So here, percent by mass, molarity, mole fraction, molality, percent by volume, and parts per million. Now, we will also discuss the colligative properties of solution, the effect of concentration on non-electrolyte and electrolyte. You know, this electrolyte balance in our body, they are very, very useful to us. No, why is it that somebody, like for example, I give you an example. When you do playing, doing vigorous exercises, or doing uh, or even in playing, di ba? You keep on sweating, and then you release no sweat coming out of your body. But don't you know that you keep on drinking pure water? By doing that, you are destroying the balance, the electrolyte in your body. When you keep on drinking, di ba, we know that water is good to replenish or to replace the water that come out of our body through sweating, but by drinking water. Actually, some athletes have died because of that collapse. And why? It is because of the electrolyte imbalance. This is the rationale. Now, when you sweat, you are releasing what? Fluid from your body. And that fluid is not only pure water. There are minerals like calcium, potassium that is being released. And when you drink water, water has no what? Has no minerals. Okay? Again, when you drink water, water has no minerals to replace the minerals that has been what? Has been released by way of sweating. So it is not by the more you drink pure water, the more you deplete. Again, the more you drink more water in your body, the more you deplete your body with the essential minerals. Because you sweat again. And what happened? The minerals from your body is depleted. So what is the best solution to this? So when you what you have when you drink, it's not only pure water. So that's why we have that knowledge about electrolyte to balance, no, the minerals and the flow content or minerals in our body. So, energy drink, it could be. But not all the time. Siguro nga mag-dependent na ta sa energy drink. So, one way is before drinking, you need also pinch of salt, add in your water and drink, or you eat other things that rich in different minerals like pananglitan si tennis player, no, kaya si is that the Grand Slam nga perme mag Grand Slam, it's not Nadal, at even most of them mga tennis player, they are eating banana. And what's that? Banana is rich in potassium, and it's good, that mineral is good for the heart. Okay, so that athletes and players would not collapse because of mineral imbalance, no. So that's it. So this lesson also is related to that. No. So how important is this lesson? We know the concentration, the solvent, the solute, and the electrolytes in our body. Okay, so I think we discussed the most important part of this lesson. Just a little about effect of solute concentration on the colligative properties of solution. We have the vapor pressure lowering. Okay. Number 2, we have the boiling point elevation. And we have the freezing point depression. Okay, these terms are really new to us. Freezing point depression, I will also explain this. No? So, next meeting. Okay, so in summary, to summarize our discussion this morning, the concentration of solution can be expressed as percent by mass, mole fraction, molarity, molality, percent by volume, and the parts per million. According to Raoult's law, the partial pressure of a substance over a solution is equal to mole fraction of an times the vapor pressure of pure substance. An ideal solution obeys Raoult's law over the entire range of concentration. In practice, very few solutions exhibit ideal behavior. So the choice of concentration unit is based on the purpose of experiment. For instance, the mole fraction is not used to express the concentration of solution for titration. Okay, this is a very good experiment supposed to be. You know that titration? That's you know how by this experiment, I don't know. I have done this on my students 2 years ago. No, titration process. That's how to analyze the parts per million. Oh, you can neutralize the base by way of using this titration method. No, very no supposed to be. This is one of the experiments that we need to study in general science too, but we cannot do it. Maybe I can just demonstrate this if I have time. Okay, so in electrolyte solution, the interaction between ions leads to the formation of ion pairs. The Van Hoff factor provides a measure of the extent of dissociation of electrolytes in solution. Okay, so kuha na ta. So I will be discussing more of this piece by piece starting tomorrow. Tomorrow is Wednesday, Thursday, and then Friday. We can finish this whole module. Okay, so I think we're done with our discussion for this morning. Thank you for joining us in this class, for joining, for attending your classes. So if you have some inquiry, you can just type. No, you can just message me through the Telegram or other means of communication. So I'm very happy for this time that though our internet is is troubling us, but uh, we have still joined together for this live stream and also for learning together. Okay, thank you everybody. Have a good day, and you can start doing some of your other activities now, even in your other subject. Okay, thank you very much. You're always the four of you is always active now on this live stream. Okay, so next week we will be starting with the second quarter, no? Second quarter na ta. Actually, after module 4, second quarter. This topic even is already for the second quarter, less module 5. Okay, so thank you. In this video, I'm going to discuss phase changes. Phase changes occur due to absorbing or releasing of energy. Energy is either absorbed or released. When energy is absorbed, it is called endothermic. And when energy is released, it is called exothermic. Therefore, phase changes occur due to either absorbing or releasing of energy. Example for this is melting. Melting is a change from solid into liquid. On the other hand, freezing is the opposite of melting. Freezing is from liquid change into solid. Boiling is another example of phase change where a liquid changes into vapor. But not all vapor or gas, but not all gases are considered as vapors. Like for example, hydrogen, oxygen, nitrogen, and all other gases. When they remain gases under normal room temperature. And when you increase the temperature, they are still gases. That means we consider vapor or liquid turn into vapor when it comes from solid. And when you increase the temperature, it changes into gas or vapor. A vapor is a gas from a substance that is usually a solid or liquid at room temperatures. So not all vapor coming only from liquid. It can be also coming from solid materials. Example of vapor is water. When you boil, it changes into steam and into water vapor. Another phase change is evaporation. Evaporation takes place only on the surface of a liquid. Now, what is the difference between evaporation and vaporization? In evaporation, process by which liquid changes, it is a process by which liquid changes in its vapors at a temperature below its boiling point. Whereas in vaporization, process by which liquid changes to its vapor at its boiling point. Take note of the difference. Evaporation below its boiling point, whereas vaporization, the change takes place at its boiling point. Another, evaporation takes place at all temperatures, whereas vaporization takes place at only fixed temperature, its boiling point. Another difference, in evaporation, temperature may change during evaporation, whereas in vaporization, temperature during vaporization does not change. In evaporation, it is a slow and silent process, whereas in vaporization, it is fast and violent process. Next, evaporation takes place only at surface of liquids, whereas vaporization takes place over the entire mass of the liquid. Another example of a phase change is sublimation. Sublimation is a direct change from solid into gas without becoming a liquid. Our example for this is uh, carbon dioxide or dry ice. Take note that sublimation is the reverse of deposition. Another example is naphthalene or mothballs. We know that naphthalene, after placing it on our cabinets for several days or months, it will uh, gone and it will not change, or there is no melting process during the sublimation process. That means naphthalene or mothballs sublimates. The nature changes the water vapor